Welcome to the January Zebra Technologies DevTalk webinar. My name is Dan Qualiana. Really pleased to have everyone joining us. This month we have Darren Campbell, Senior Software Architect at Zebra, who's going to be talking about Google Mobile Services and how to use that in an enterprise environment. It's really nice. Darren has been doing a blog series on this topic, and now he's going to be going through in webinar format so that we have a better chance to hear from him and be able to ask any questions we might have about how GMS is used. If you do have any questions, please feel free to enter them in the chat window, and I'll be monitoring those, and probably at the end of Darren's presentation we'll be going through those. I did want to remind people that if you are interested in catching up on any of the old webinars that we have done, you can find those either on YouTube in the Zebra Technologies channel. We have a whole playlist of all the old webinars, and you can also find them at the developer portal, which is at developer.zebra.com. So again, I'm really excited to have Darren here. I did also want to do a little bit of a plug for a few things. We have started a podcast series as well. So we're putting that out every month. So you get to hear myself and one of my colleagues, Mark Jolly, who is in our UK office, talk about some of the trends and things that are hitting our developers. We're trying to interview different leaders from across our global organization to get different perspectives on that. And then also a little heads up, we are in the midst of doing a refresh on the developer portal. So over the next few months, we're going to start rolling some of those changes out. And what you're going to see is really more of a change to the layout to try to make it easier for you to be able to find the content and the information that you're looking for. So hopefully that's going to be a great change for everyone. So now I'd like to turn it over to Darren so we can hear more about GMS.
Okay, thank you very much, Dan. Yep, I'm happy to be here. I'm going to be going over some of the GMS features that will be useful in an enterprise deployment. And so I know this is a topic that really goes beyond what you typically be involved with as a developer. It's really quite an amorphous topic, and I know there's a lot of people on this call who are not necessarily developers, but because this is a dev talk, I've tried to aim it at features that a developer would find interesting, and that will be the first half of the presentation. We'll be going over the feature differences between GMS and non-GMS and some of the benefits of GMS in your enterprise. And then the latter half of the presentation, I've got some code lined up, and we'll be going through some actual samples and APIs, so hopefully that will be more interesting to hardcore developers. So hopefully something for everyone in this presentation. But just to make sure we're all level set, first of all, what is GMS? What are Google Mobile Services? So these are the features that Google have created. They're proprietary, closed source. A lot of people will think of GMS as the Play Store, just the Play Store. Does the device have the Play Store? But it's a lot more than that. Well, the APIs, you can see a splattering of them on the screen there. There are services and there are APIs, all of which really form this single bundle that we call GMS. And it's not like a GMS version of the code and a non-GMS version of the code. This is, think it was something amorphous that goes on top of AOSP, the Android open source project. So when we're offering this choice of builds to choose from, your choice is between either AOSP or AOSP plus all of these great GMS services and applications and APIs. And so let's a little bit more detail then. Applications. So Google have, I say just the Play Store, maybe others that's come to mind, Maps, Chrome, YouTube. I've tried to italicize the applications which are more interesting to enterprise users and enterprise developers. The key here is that we are replacing functionality that was either present but not as feature rich in AOSP or just absent completely. So I normally use the example of the email client. So there is an email client on an AOSP build, but it does not do Exchange ActiveSync. If you receive an email, you'll get a notification, but there won't be any grouping of that notification into subjects, for example. And these are all things that Gmail does. They're features, and you get it for free. It's not like you've had to develop this email client yourself. It's not like you've had to download it, somehow sideload it from the Play Store. It's present on the GMS device. And this pattern is really true for all of these GMS apps. They are functionally superior and updated more frequently than their equivalents that you would find on AOSP. So the other popular one is Chrome. Obviously, this is updated every, I can't remember off the top of my head, but very frequently, whereas the browser part of open source project is either not as feature rich. I know it does get security enhancements, but yeah, it hasn't certainly got as many features. Like, it doesn't have service workers. We'll go into some more detail of this later on. APIs. Now, with APIs, we're not replacing anything in AOSP. So the APIs available on GMS builds are in addition to the APIs on non-GMS. So if you have a mixed deployment and you want to target like the lowest common denominator, you know you could target the non-GMS APIs and they would work across all of your devices. I mean, practically, you'd probably have multiple flavors of the same application, and one flavor would be for GMS, and it would load in the GMS APIs because, again, like the applications, they are functionally superior. And I've got, like towards the end of the deck, we'll go over locationing as an example, and some of the awareness APIs and SafetyNet. We'll cover that later on. That link there links to Google's page where they list out what all of these APIs are. Another benefit, we as an organization have had to pass a couple of test suites, the CTS and the GTS, to prove that well, I say prove, but we have to pass a series of Google mandated tests to prove that we have created a device and implemented these applications and services on the device in such a way that they work in a consistent fashion. So you know if you have an application or a library that already works out in the field now, you can port that to our devices or to a GMS device in general, and it will work as you would expect on Zebra devices. So there's some of the benefits. Now, as Dan, I was going to say as Dan alluded to, but as Dan stated in the introduction, I'm currently in the process of writing a series of posts on our developer portal, developer.zebra.com, and I'll plug them here. I tried to release one about every 3 weeks or so, and the subjects of these are based on questions or comments that I've been receiving or my colleagues have been receiving from the field. So I started off with people were asking, well, I deploy my applications via the Play Store, but I don't want them updating in the field without my knowledge, just haphazardly, ad hoc. You know, I want to have some control over the versions of those applications. And the post goes into some detail of how to do that. Google's terms and service, people have maybe concerns, maybe questions about what exactly they're signing up to when they tick that checkbox in Google's terms and service. Obviously, you could read what Google put online, but I try and address some of the most common questions in that post, and you know, et cetera, et cetera. We've got some more posts lined up coming in the next couple of weeks or so. And in all honesty, if there are questions coming out of this presentation, then I'll add additional content. But just for the purposes of this webinar, let's just go over some of the recommendations and conclusions which have come out of those posts. If you know, because it's easier sometimes to listen rather than read through it all. So first of all, I said earlier on the Play Store, most people think of the Play Store as the game changer, or you know, essentially the main difference between GMS and non-GMS. As it stands, the Play Store on your consumer smartphone, you need to log into it with your personal Google account. And then you as a user have to choose from millions of applications, and you download them and you can uninstall them as you like. It doesn't really work in the enterprise. I mean, I know people have done that, and there is ways of blocking certain like you can stop the user from uninstalling apps is what I mean. The main vector that you would use here is the managed Play Store. So just be obvious. Let me just be clear about the difference between the Play Store and the managed Play Store. The managed Play Store exists on the managed device. A managed device is a device which has a device owner, which is an EMM client application or some other application configured to have control and access to the device policy manager API. So if you read through Google's documentation on device owner or this corporate owned single use model of devices, this is a managed Android device. So with the managed Play Store, it differs from the Play Store in you only get a curated set of applications. So the IT, the organization is able to control which apps you as a user have the ability to download on the device through this managed Play Store. And you can also automatically install those applications. This is all managed via the EMM. It's a lot more professional and enterprise grade experience. And there's a blog post I put out there. If you have questions or you want to try this out, then go and have a look through that blog. It's a good way to test it without even having an EMM. Google have a sample EMM you can use, and it works on our devices. I've tried it. There's some demonstrations online. The other difference here is the managed account versus an unmanaged play account. So a unmanaged play account would be like a personal Gmail account. You're the way that you're doing this on a consumer smartphone. With a managed play account, this is a way of signing into Google Play without needing to give Google any of your user credentials. It's all managed to the EMM level. And optionally, you can also connect your organization's user database with the EMM. There's some API there so that the EMM is able to provision devices, but you don't have to pass any of this through Google server. So if you're using a managed Play Store, you would be accessing that via a managed Play account. At no point do you have to enter your @Gmail address. The other distribution channels, just to jump around the slide a little bit, they're not going away. So let's say right now I go on the website and I buy some Zebra devices and they have GMS on. I'm still more than capable of installing applications through ADB. By sideloading those apps, I can copy the APK on and use the file browser to install them, or even, I say unmanaged EMM provisioning. The terminology might differ, and honestly, if you go onto your EMM's website, then they'll have webinars on this and documentation. But if the EMM is provisioning your device in an unmanaged way, so they might call it legacy mode, that will still work. And Stage Now, of course, exists as a technique for installing and uninstalling applications at stage time, as it always has done in the past. Be very aware that there are security benefits to going with Google Play. So this 0.05% of devices that have Play Store have 0.05% of devices that use Play Store. Oh, that's a really poor way of wording that. Let me try and make that a bit more clear. So Google have released figures. I think these were based on 2017, and we have presentations based around this where there are potentially harmful apps out there installed on Android devices. The vast majority of those are installed on Android devices which do not have the Play Store. So just by having the Play Store on your device, by being a GMS device, you are automatically now in that group of devices which have far, far fewer potentially harmful applications on them. And like I said, there are information on the developer portal that goes into detail of those figures. Final point here, there's no legal way to get Play Store apps on your AOSP device, so it wouldn't be supported, so just don't try it. In terms of updates, so this was the outcome of the post I gave. Just recognize that there are a number of components that make up your full Android experience on your device, and there's a number of different ways that you can update those components. So things like the operating system itself, security patches, that's under full control of your EMM or IT admin. They can install like lifeguard updates whenever they see fit to do so. Unlike in the consumer sphere, when you get updates pushed to you on your smartphone when the carrier feels like it. Apps, built-in apps not in the Play Store, so things like Data Wedge and Stage Now, these are updated as part of the core operating system. Private applications, again, under your full control if they're not in the the Play Store, then you choose when to update those. But applications which are downloaded via the Play Store, you can disable them being updated. Of course, you can enable them as well, so you always have the latest version. And Google, this is an area where Google are actively working to improve the experience for applications that are updated via the Play Store. And it's a request that's coming from us. We're working very closely with Google in that area. Play services, special case, you can't choose when and if those get updated, but I mean, this really just only applies to people who are using these GMS-based applications, and you would probably want to always be on the latest version of those regardless. So on to the next post then, analytics. This is where I tried to cover some of the concerns with the Google privacy policy in terms of service. Something I recognized in the field, a lot of people don't make the distinction between the different types of analytics. So just so we're being clear, there are, well, probably a lot more than this, but just I've classed it as 3 different types of analytics. So device analytics, things like the device phoning home to say, here's a location update, or just any kind of other diagnostics. These are the diagnostics which can be disabled with the through either the setup wizard, or you can also do it after going through the setup wizard in this usage and diagnostics window. Analytics from Google's system applications. These are things like Chrome and the Gboard, the Google GMS keyboard, which are part of the GMS application suite, application bundle, which will quite separately from the device send analytics back to Google if you opt in, if you tick that tick box that says you're happy to do so. But don't forget, if it's a particular concern of yours to be sending data through Google servers, remember Google own Firebase, and Firebase is a huge analytics provider, and it's the analytics provider that I use when I manage like websites voluntarily on the side. But they I'm using Firebase Analytics because it's really, really good in all fairness, and it's really easy to use. And it's not clear to me which of the thousands of applications, millions of applications in the Play Store are using Firebase Analytics as opposed to any of the other hundreds of analytics providers. So just be very cognizant of that. You probably need to sniff the packets to disable that, to detect that, sorry. How do you disable it? Well, you can use settings. In my post, I go through a number of settings that you need to use, and we're looking to automate some of those, but at the moment, the most easiest way to do that is at the network level. And to be honest, a lot of enterprise customers are already using VPNs, already using firewalls, so you can selectively choose to disable the network access for some of this analytics. Most recently, again, changing focus, I had a post on the differences between the AOSP and the GMS applications. So I've just picked out a few here. This is really building on the point I made earlier in the presentation where I was talking about the email application was less functional on non-GMS compared to Gmail on GMS. So here's a more thorough table, if you will, giving some of the comparisons. There's an updated keyboard, there's an updated browser application. I've put, you might get Chromium on some of our non-GMS devices. This isn't like a company policy moving forward that AOSP will have Chromium on Nougat, so you might have to install a third-party browser, just be aware of that. But certainly on GMS, you're guaranteed to have Chrome, thumbs up with that. You'll get a more up-to-date web view and just, like I said earlier, better applications in general, more up-to-date applications. A lot of people then say, well, it's great that I've got these applications, but I would like to disable them. And you can do that as well. We have the feature, the MX Application Manager. Just be aware that there's certain applications that you should not disable, like the package installer. We will prevent the device from booting, I'm told, by our like low-level design team. I couldn't tell you exactly why, but it does, so please don't disable that. Incidentally, I did do some analysis personally on that, and I can guarantee that that application is not phoning home or doing anything nefarious at all on the devices. Other impacts, if you disable the GMS keyboard, obviously you're not going to have a keyboard, so you might want to like post-load an alternative keyboard. I can personally recommend Enterprise Keyboard from Zebra Technologies. I hear it's really good. And another, if you disable the Playstore, you won't get application updates. If you disable Chrome, it's interesting. If you disable Chrome, you obviously won't have a browser, but enterprise browser, even on Nougat devices, continued to function. I tested it on my my TC51. So even though the functionality of the web view is delivered through Chrome on a Nougat device, by disabling Chrome, you are still able to access applications that require a web view. I was a bit surprised when I found that out, but there you go. That's the latest. Certainly in my, I haven't tested every device, but that's what I have observed. That covers all of the posts that I've given so far. I do have some upcoming posts on location services. This is an area where an awful lot of enterprise customers have location use cases, and for some of those customers, the location services that Google provides on GMS devices will be of great help. And actually, I'll cover this a little bit later in the deck, but for the purposes of this slide, let's just mention things like location history and Find My Device. And Find My Device may be useful if you're not using an EMM. I know this will be the minority of our customers, but if you're signing in with a personal Gmail account for each one of your users, maybe you have a user normally associated with a device, you're able to locate that device and remotely wipe it or remotely activate the PIN if it gets stolen. It's value you're getting for free if you choose to use it. So like I say, it will be a minority of enterprise users, but it is there. You get better developer APIs for locationing, and you also get additional APIs as well, things like awareness. There are settings that you have to make sure that you have enabled in order to use these location services. You can either do this when you go through your setup wizard, or you can also do it through manually in the device settings, or if you're using a managed device, there is a way to enable or disable these via your through the device policy manager APIs. I'm not sure exactly whether every EMM exposes the functionality, but the EMM is able to do so should they choose to implement that at the Android layer. And finally, then, for this list, I just want to cover factory reset protection. This is a security feature which Android have implemented, and in all honesty, it is a security feature which is aimed at consumer devices more than enterprise devices. But here at Zebra, we take security incredibly seriously, and so we're not looking to enable any kind of bypass for this. So it's not going to go away. Factory reset protection is here to stay. But having said that, what is it? So if we have a device with a personal Google account associated with it, so it's probably the minority of enterprise devices, but let's go with it, and an untrusted reset is performed, come back to that in a minute, then the account needs to be verified on startup. And that looks like, I've got a little screenshot here. It says verify your account. This is a device which is, a GMS device has undergone an untrusted reset, and now it's asking me to enter my Gmail account that was previously associated with the device. So an untrusted reset typically would be if you're using Google's Find My Device and some vile fiend has stolen my phone, like I say, it's a consumer use case mainly, and I, as the phone owner, want to prevent the vile fiend from doing anything with my phone. I can log on to the Find My Device I explained in the previous slide, and I can remotely wipe the device, and then the evildoer would need to enter my Google account, which of course they don't know, and my password, which they definitely don't know. An untrusted reset, this is where we get into, consider this in your enterprise devices though. Anything you download from support.zebra.com/downloads, I believe it is. So these package updates, these reset packages, factory reset, enterprise reset, they count as an untrusted reset. So bear that in mind. If you're loaning devices out, if you intend on borrowing a device, make sure that the account has been removed before that device is returned to its rightful owner. And with that, we've covered the first half of the slides that I wanted to cover, and now we're going to dive into the developer differences that we find in GMS. So in a little bit more detail here. So it's not just new APIs, there are also additional system components that are available. I mean, the most commonly used ones are Maps, Chrome, and Location in Enterprise. That's the same link I gave before, but all of these APIs are listed under that link from Google. Have a look at it. A lot of our customers have use cases around sending messages, so cloud messaging. And this is what was previously Google Cloud Messaging, now Firebase Cloud Messaging. The ability to send a message to a device, I want to say asynchronously, but there's no kind of guaranteed delivery, but it does get delivered pretty much instantaneously, depending on network conditions. That's Firebase Cloud Messaging. That's only available on GMS devices. I will say, though, note that Firebase is a really complex suite of functionality that was developed separately from Google by Firebase, the company, and then Google acquired them probably 2014, I guess. But some portions of Firebase will work on AOSP. I don't have any specific details of this will work and that will work, because that will probably get out of date very quickly. But we had a 2016 hackathon competition here in the UK, and the winners of that competition, and indeed the runners-up and the people that didn't win, all used Firebase on a TC8000, which of course is an AOSP device. So this was the database backend and I think it was user credentials as well. So when I say Firebase is GMS only, it's not the whole of Firebase, so take that with a pinch of salt. But certainly cloud messaging is definitely GMS only. And again, I want to stress this point, GMS APIs are a superset of AOSP APIs. Anything that worked on AOSP will continue to work on GMS, but not vice versa. You can't target a GMS device and have it work on a non-GMS device. So be aware in mixed deployments. Doze Mode is it's a favorite of mine to talk about, because I've been doing these updates in the latest version of Android now for Marshmallow and Nougat, and one common update that always gets a lot of interest from our developers is Doze Mode. Doze Mode was introduced in the AOSP code base, but it's only enabled on GMS builds. That's how it managed to weasel its way into this presentation. It's great because it helps extend battery life. That's like the headline here. However, a lot of customers, it's great that you're extending my battery life, mate, but we're not happy that, we're not able to run in the background like we used to be able to do on AOSP devices or on Lollipop devices. So it's not just a unique concern of GMS here. I do have an existing blog. Maybe that's the running, I need a tally of how many times I've mentioned previous blogs, but how to keep your application running when the device wants to sleep. And in there, I go through things like Wi-Fi locks and wake locks to, keep your application awake. One thing we cover is avoiding your application being subject to Doze Mode. So Doze Mode affects the device, but applications on the device, there's another, app standby is another term, but here we'll just say Doze Mode. So you want to whitelist your application if you don't want your application to be subject to all of the restrictions of Doze Mode. So a whitelisted application will be able to maintain wake locks and will be able to run in the background and have access to the network, even though the device itself is still subject to Doze. And the great news for users of our Nougat devices that are running MX 7.0 and above is we now have a way to do this programmatically using MX. So previously, you had to do this by sending a special intent in Android, and that intent, there's two versions of the intent. One intent would get you kicked off the Play Store, so that's not great if you want to use the managed Play Store. Although I did try it and they didn't kick me off. But the official line is they'll kick you off. And the other way was to get the user to manually whitelist the app, and obviously that's always going to be subject to error. But now we're able to do that automatically, and I would like to share with you an example. So this demo example is my application I put together in conjunction with the previous blog post to show an application running in the background. Here, we're going to use the EMDK, which is the programmatic way of accessing our MX value add layer. And we're going to, I don't know why I'm pointing with my finger here. We're going to use where is it, action. So the action is going to be battery optimization, and we're going to remove optimization from this application. And what that's going to do, that's going to add us to the whitelist. So let me just show a video of that in action. And I'll pause it and just explain. This is a TC51 running the, I think there's only one version whilst I'm giving this presentation of the NuGet operating system. And I'm just going to show the various versions here. Here you go, so it's running 7.1. And if I look at software components, it's running MX 7.1 there. Oh no, 7.0, sorry. But this functionality will work on MX 7.0 and above. So notice now how the application is not optimized, so it's not whitelisted. No, it is optimized, sorry, so it's not whitelisted. And now I'm going to click this Add to Whitelist button, which is going to do the code that was on the previous slide, and then go back into settings. And whilst the video is playing, I'll take this opportunity to say that this functionality is not available on the value tier devices, so the TC20. So here you go, now the application is whitelisted, it's not optimized. So to what I was saying about the TC20, this is part of an MX feature which is not available on those devices. But just to complete the demo, back into settings here, and I've now removed the application from whitelist, so it is subject to being optimized, so it's no longer on this non-optimized list. Okay, hopefully that made sense. Moving on from Doze Mode, we have other system apps. I just wanted to pull these out. You can now, on a GMS device, you can add a maps activity that you couldn't do previously. Really useful in transport and logistics use cases, because you get a lot more visibility outdoors of where your devices are. You can easily present that on a screen without third-party mapping applications that maybe require a license. Maybe they're well, I've not used them myself, so I don't want to comment on how easy they are to use, but I know Google is easy to use. Excuse me. These two screenshots here are my ability to, my attempt to make something a little bit bland appear interesting. So just bear in mind that on a GMS device, Chrome, so this middle screenshot here is Chrome, and it's I'm visiting this, what is my user agent, and I'm running Chrome version 60 with this device and this build. If I install Enterprise Browser on this device, then notice how it's using the same rendering engine, although with this strange WV, but it does have the exact same version of Chrome. It's using the rendering engine from Chrome. This is a benefit of being on a GMS device. Actually, one doesn't exist, but if you can imagine a TC20 AOSP build, if that existed, then this would be a much older version of the browser. It would be the browser from possibly based on WebKit, although that might not be true of NuGet devices, based on what I was saying earlier. Moving on, SafetyNet API. This is a hugely powerful set of APIs which Google have. SafetyNet is the umbrella term, and there's the link there to Google's pages for SafetyNet. At the moment, there are 4 APIs under there. At least when I put this slide together, there were. So attestation, I'll demonstrate that on the next slide. But safe browsing. So imagine you did have a application with an inbuilt web view. Using the Safe Browsing API, I am able to determine, or I'm able to prevent my users from going to a URL that Google deems unsafe. So the functionality that you already see in Chrome, where if you try and go to a dodgy site, then it will give you the, hey, are you sure you want to go to this dodgy site from the link that your friend has sent you? Then you can back out of that, and you can add that functionality now to your web view based app. I believe they will be adding this to Enterprise Browser at some point in the future, although I don't have a timeline for that. It would, of course, be an optional feature. It wouldn't be mandated to be turned on. ReCAPTCHA API is just an easy way of implementing captures. Captures have come on a long way since a few years ago, where you had to click the images of street signs and cars, which probably were just there to train the AI to self-driving cars, in all honesty. But here, well, nowadays Google have patents for they look at how your finger is moving on the display and how the mouse is moving. So this is a way of implementing a capture API based on Google's powerful captures, which are less labor intensive for the user. Verify apps, really interesting one. So I might have skipped over this. I don't remember saying it on this call. Verify apps is a feature on GMS devices where you can be sure that the applications installed on the device have gone through Google. Well, Google have not identified them as potentially harmful applications. So there's a number of ways Google identify apps as potentially harmful. Anything I upload to the Playstore or the managed Playstore is scanned by Google for using their clever heuristics, and obviously it's an industry secret how they do it, but they presumably extract the class files and the Java and figure out which APIs are being called just to determine that it's not a potentially harmful app. And they've probably got a database of PHAs that have been found out in the field, and a digest for those just to check that you're not matching any of those PHAs. So with this API, after that tangent, we can determine whether Verify Apps is switched on or not on the device. This is something that banking apps will use to make sure that they're not running on the same device as a potentially harmful app that could try and steal your banking data. So you might want to, again, use this API to make sure that the user has turned on the Verify Apps feature. It is a setting in Google. You can turn it off as a separate setting for upload. Like if I sideloaded an APK to the device and the setting is enabled, it's optional, then Google will upload that APK to their servers for scanning and make sure that you're more thoroughly protected as a user. I missed out the attestation API. This is to make sure that the security and compatibility of the Android device on which you are running is trusted and uncompromised. So what that means is the device has not been rooted. The device is based on a build which Google recognizes. So that CTS test that I said Zebra have to pass earlier, obviously we have to submit our builds to Google to do that, and Google have this database of builds. So is this build part of the CTS database? And I'm going to show this in the next slide. This is an example from the Google Samples Android Play SafetyNet. Now, in order to use the attestation API, there is a client portion and and a server portion. It's not recommended to run the client and the server portion all on the device, because if it's a compromised device, then you could a clever developer, nefarious developer could just return true on a compromised device. So the idea is that you would typically run the client component, get this really long string, and then upload that to the server, where the server does its own logic and responds back to the device, yes or no, you are a trusted device, or then the application on the device knows, hey, great, I'm trusted. So both of these samples are available in Google's GitHub. So this is the same device as before, just running the SafetyNet sample. You just click on the verify device there. It calls down into the API. It's just a couple of calls, and you get back this request. Now, typically you would upload this via an SSL connection or something, but I'm just going to save it on my Google Drive, and I'm going to run the server side of the API on my desktop. So Google very helpfully provide a Java-based server API which you can just run with Gradle. So I'm just running it on my desktop, but imagine this is running on a server somewhere. I'm using VLC here because the version in the slide deck, I don't know what happened to the quality, but it's very, very low. So hopefully this comes through on the presentation. Okay, so just get the file. This is uploaded to Google Drive, so copy all of that. That's what the device produced, and then run the server portion of the component. So it's a Gradle compiled application. Run online verify is the argument to Gradle, and then this sign statement is all of that thing that I just put in the clipboard. And then Gradle's going to do its magic. I probably could have sped this up. So this is obviously running quicker on a server. As here we are. I've paused it here. The most important bits. This is just what's output from the test application, but we get these two bits here. CTS profile match, true. So the device on which I got that signed statement is a device which Google recognized has passed its compatibility test suite. Great, thumbs up on that. We now trust the device is a known device, not some knockoff device. The basic integrity match, true. That means that we have confidence that the device is not rooted. I mean, there are ways to detect whether the device is rooted with MX as well. It's not specific to GMS, but this is an industry standard way of determining compliance. So here we are, basic integrity match, true. The device is not rooted. Great stuff. Here we go. I'm going to highlight them here as well. I don't think there's anything else. There we go. So that's the video. And then, okay. So I've been promising throughout this presentation to get to the location bits and pieces. So here we are, we're finally at the location enhancements, which are introduced in GMS. Now, I should preface this by saying most, if not all, of the location services and abilities of the device are functional mostly outdoors. If you're a transport and logistics use case, if you're a package delivery company, a courier company, then these APIs are really, really useful to you. If you are, you want to know your location indoors, they're, in all honesty, not as useful. It's a device, it doesn't have GPS indoors, the Wi-Fi coverage might be spotty, your mileage may vary, as they say, and if indoor use cases are something you're interested in, then we've got a whole division. We, Zebra, have a whole division of people who'd love to talk to you. Location services probably aren't the answer to you, but these are free. You've already got these on a GMS device. Let's understand them and use them if we can. So the old point that I was saying previously, that if it's GMS, we get everything. We get location services and we get location manager. AOSP, you only get everything in this left-hand column here. There's the two links, which I always struggle to find on the Google Developer Portal, so there they are. With Location Manager on AOSP, it's up to you to determine the most accurate location available. If you've got GPS position being given to you every 20 seconds, and you're getting the network, the cellular position given to you every minute, they've got different accuracies, there's different ages. I mean, there's algorithms online to do this, but honestly, it's easy to get it wrong. Location services, you've got a single source, the fused provider. It's the best location available from any API on the device, and I've used it extensively myself. I've written a number of applications that use these location services, and I can confirm that. Certainly sat in my study here. Obviously, I've not been all over the world testing this. Maybe well, I'd like to, but that's probably a common joke. So what else have we got? Accuracy is good with Location Manager, but better with Location Services. You also get additional features with Location Services. I mentioned earlier on activity recognition. So this courier use case. If I know whether my device is driving or walking, I know whether the courier is en route to a destination versus if they're just walking around delivering parcels. I get a lot more knowledge of what the device is doing. And in all honesty, that is available, and it uses the gyroscopes on the device. You don't even need to have a network connection to use the activity recognition feature. Geocoding, going from a latitude, longitude to an address and vice versa, that is available only on GMS. Very useful to, again, to these kind of courier or TNL use cases. This diagram I made for previous blog post, but I've put it here because I put a lot of effort into it, and I'm really proud of it, even though, well, I'm not an artist, so give me a break. Everything in blue is available everywhere, AOSP and GMS, and everything in red is available on GMS only. So if nothing else, that gives you a visual representation of how much more locationing capabilities you get on GMS devices. And this is just an example of the enhanced geofencing. So on AOSP devices, you are able to specify a radius around a single point and say, tell me when my device goes in or out, so enter or exit only of that radius around the point. With the GMS devices, the more powerful API, I can define multiple geofences, and I can also get notifications whether I dwell within them. And anecdotally, my personal testing with the same device with both these APIs, the GMS APIs appear to be more accurate. I also saw a Google presentation where they spoke about the way they manage these fences to make it more efficient. Like if I was to create a fence in Abu Dhabi and I'm sat here in the UK, my device will not even bother checking the Abu Dhabi fence until I, in the UK, go near an airport or a port or any other way of getting out of the country, because it knows that my device has got no chance of being anywhere near the Abu Dhabi geofence. So I was really impressed by that, and I've never tried that myself, but yeah, I thought that was a really good idea of how they implemented it. So location APIs, awareness. So when you use these awareness APIs, you're able to construct if then else, if this then that statements. So I mean, the second one, for example, if the device is stationary outside of the office and it's 7 p.m., the device is lost. If the user is running and the device has exited this geofence I've put around the building, then the device is being stolen. I think the key point here is you could do all of this yourself. You could write the logic for creating a fence, and then what time is it, and then periodically checking all of this. It wouldn't be very efficient because you have to check the time and check the location within a fence. Google just give you a callback when any of these things are true. So look into them if they're useful. If these kind of use cases I've put on the slide here are useful for you, then you know, maybe the awareness APIs would be useful in your implementation of your application. And all of these APIs, incidentally, I've got an application, I've called it Location API Exerciser, and it goes through all of these in a very basic way, but just showing how they might be used. And the link is at the end of the slide deck. Okay, so we're getting a little bit nearer the end. Firebase APIs, Firebase Cloud Messaging, I covered these briefly earlier. So, I mean, I'll say it again, Firebase is a lot more than Firebase Cloud Messaging, but the reason I keep harping on about Firebase Cloud Messaging is because cloud messaging is, well, for a lot of our businesses, it's a primary use case. They want to be able to send messages to devices. And by using Firebase Cloud Messaging, you're doing it in, well, all of those reasons on the left-hand side to use Firebase Cloud Messaging. So for me, the ability to bypass Doze Mode and the upcoming restrictions in Oreo, you can always specify your message to be high priority, and you know it will be received on the device, even though the device is dozing or the device is subject to these Oreo background restrictions. When we start having Oreo devices, you know, your message will get through. It's very flexible, certainly more flexible than some of the alternatives I've seen out there. You can have topics and groups, and you can specify the text to appear in a notification all at the server side without having to worry about what goes on the device. It's the recommended provider by Google, and we've seen other, I mean, we've dealt with customers who want a cloud messaging provider, but they don't want to use Firebase Cloud Messaging for whatever reason. You know, there's valid reasons for not wanting to use it. And once you've made that decision, you then have to say, well, I need to whitelist my app, so I need to go through the samples I was showing on the previous slide. I need to manage this ability. You know, I need to either buy in a third-party cloud messaging solution or create my own. Power efficiency is a huge concern of these cloud messaging systems, because obviously you need to be awake to receive the message, but if you keep your device awake all the time, your battery's going to run down. So it's just another reason to go with Firebase. All the the complicated concerns have been taken out for you. I've been told off in the past for associating cons or bad things with any of our devices. That's why these are called pros and not pros. That's my new terminology moving forward. Okay, so final content slide then. We've got these are just some other APIs that I thought might be interesting to enterprise developers. So the Vision library, this gives you the ability to detect faces and recognize text. This kind of cloud API was all the rage a couple of years ago. All the major operators like Microsoft had their own cognitive services APIs, and this is obviously Google's version of that. All of that is free, great. You know, obviously you have to have an external connection to Google servers, so but it's there. It avoids you having to write a face detection algorithm, however one would go about doing that. There was also, the key point here, there's a scan barcodes functionality built into the Vision API. And you think, well, that's great. I've just got to have the same API running on a consumer device and a Zebra device and a competitor device, and it would all work the same. I don't have to worry about specific SDKs. No, it's not quite. If you want to do that, incidentally, then look into using Data Wedge. But this scan barcodes ability of Vision is really designed for augmented reality scenarios where you're kind of browsing around in VR and there's a barcode on the wall and I scan it by touching it with my hand. But so yeah, it doesn't even use the barcode scanning hardware of our devices. So I wouldn't recommend using it for intensive scanning applications. And so I know there's been a lot of content there, but with that slide, I'm done for content. So these are all of the related blogs and sample apps, and there was obviously the list in one of the much earlier slides of the posts that I've been doing on GMS. They're separate. The videos I've put on YouTube, and also in the notes of this slide, there's like some online webinars given from some of our EMM partners as well that you might want to check out if you want to understand more about managed Google devices. And with that, are there any questions at all?
Darren, thanks so much. That was a really good overview. And I'm assuming the first question we'll hear from people is how do we get the slide deck that has all those great links? We will be posting that very shortly on the developer portal under the developer events page. We have a blog that's focused just on this webinar. So we'll get Darren's presentation and these slides posted up there, and we will work to get the video posted up on YouTube as soon as possible. So again, if you do have any questions, you can enter those in the chat window, and Darren will help answer them. But as of now, Darren, it seems that you did a fantastic job because there are no questions.
That's brilliant, Dan. I was hoping they would be easy questions, but I guess no questions is the easiest. But yeah, we'll hold on a little bit in case anyone asks any.
Yeah, so Darren, I really appreciate you putting all this content together. You have your blog series. We now have this presentation you went through, and I think that Zebra switching over to having a lot more GMS devices, that this is a topic people really are really trying to understand more deeply. And so it's really nice to see the actual apps that are available, how to use them, which ones are most important, that type of thing, and some of those true differences between AOSP and GMS.
And if there are any questions afterwards, then feel free to post on the developer portal or reach out to me on Twitter, and we'll get those answered if you wanted more direct access.
Well, it doesn't look like there's any. Oh wait, I think I do have one here. Hold on one sec. I have a little trouble reading these. Oh, we do have questions. I missed them.
Oh no.
Okay.
You had people screaming in the audience, Dan, saying,
yes.
I sent it in.
I apologize for that. So here's one for you. If you disable the usage and diagnostics, will this keep the EMM tool from updating and collecting analytics?
So I'm presuming we're talking about the screenshot I'm showing on the screen now, and that will only apply to the diagnostics sent by the device. So any application-based analytics, including the EMM analytics, will not be affected by this dialog here.
Okay. And let me read through these here. So there's some questions trying to get a little clarity around devices here. So they're laying out a scenario. An unmanaged device is the device not tied to a personal Gmail account, but the unmanaged device is managed through the managed play, which is tied to a corporate Gmail account.
It does not have to be a corporate Gmail account. So by corporate Gmail accounts, you can obviously sign up to Google and you get a corporate account with your Gmail and your calendar. No, it does not. These accounts are provisioned by your EMM, and optionally, the EMM may integrate with your identity database for your organization. It does not have to be a Google identity. It does not have to be a Google identity. It can be like my, Zebra@zebra.com email address. But you don't even need any of that connection. You can just have a managed device which is provisioned by the EMM. It doesn't have to go through Google at all. And to understand that better, it's quite difficult to explain it without diagrams or any of that. So if you have a look through my blog post on which one is it? It's this the managed Google Play Store. There I go into a little bit more detail. I point at the documentation on Google's website for it, and also the example EMM that Google provide. And obviously there are separate webinars from some of our EMM partners and even people that aren't our partners, and just EMMs in general, and this would still work. But yeah, that's if you want more information, then please visit those links.
Okay, so we actually have two questions that are pretty similar, and that's, so if we're in an environment that's offline or more firewalled, is there value to GMS rather than AOSP? And they're also trying to look at, there's obviously going to be some impact by having GMS, potentially draining battery or, processing speed, things like that.
So the battery draining, I don't have any data on me right now, but I know it is an area where we're looking to address that very question and give some actual data. I mean, it's difficult to get realistic battery usage scenarios. Obviously, you can't just leave a device on the table and measure the battery for an hour. That's not realistic. But yeah, we are looking to get real data on that. You can disable a lot of these GMS features if you don't want to use them, and it's a concern to you that maybe they're using battery. Personally, I mean, the example I used in the deck was for the awareness, this activity recognition, and this will work using, I mean, it's using location services, so it's only available on GMS, but it will work without a network connection. I've tested this myself on numerous times, and you'll still be told whether the device is moving, running, walking. I mean, the device isn't running, the user's running, but yeah, you still get some value on GMS even though you don't have an external network connection. I mean, that's the example that I always go to, but I'm sure there's others that I can't think of right now.
Do you know exactly how it is doing that with the location when it's not on the network? If there's any specific things that it's using to do that?
Just for the activity recognition, so it's using the gyroscopes. It knows that you're walking, or based on how the device is moving in three-dimensional space, it can work that out.
And what about location? We actually had someone say that they had the My Location feature that they had used indoors. It was very accurate. They went off of their network and it still seemed to be working pretty accurately. Do you have information about that?
So indoor locationing using any of these APIs will really depend on where you are. So it's quite a complicated topic. If you're connected or if you're in sight of any of the Wi-Fi access points indoors. Like if you're in a mall in America, these malls have been mapped separately, and that mapping information has been sent to Google. That's why when you zoom in on Google Maps on the Mall of America or any of these other kind of malls, then you will see where the individual stalls are. So yeah, you'll get great indoor locationing with Google APIs there. Around our office, where Google haven't mapped out, then the indoor locationing through these APIs is very poor. So yeah, just bear in mind that you won't always get the best of results from these, but you will still need a communication back to Google if you want Google to give you any kind of information or a location information. Sorry, that you don't, other than GPS. If you have a GPS chip on your device, then you get information without a network connection, but not all of our devices have GPS. Certainly the ones designed for indoor use, the TC20, the TC51, the TC70 and 70X. Prove me wrong on those, but I believe none of those have GPS chips. So yeah, it very much depends on your situation.
Okay, and I think there's one other question I wanted to talk. This one's kind of specific, but we had someone who said that they were using an MC33 NuGet device with AOSP, and they saw that the Chrome browser was being auto-updated. So they were curious if you have any idea how that could happen or why that would happen.
So the Chrome browser will not be on an MC33 AOSP because it's AOSP. Chrome would only be on GMS. I've seen like the only device I'm in the UK and I work from home most of the time, so I don't have like a whole rack of devices. But with my TC51, if I put AOSP on there, I get the Chromium browser, which is a browser built from the open source Chromium project. But I couldn't comment on how that would be automatically updated at all. I can't imagine how that would be. But you know, if you want more, we can follow up on that one. It sounds like we need more information on that, to be honest, Dan.
Okay, great. We can do that. So yeah, unfortunately, I missed these questions before. It looks like, oh, we just got a couple new ones that came in. Let me look here. Oh no, I think you addressed most of these. So we did have a few people asking about these links, how they can get them. So again, we're going to post this presentation with the links at developer.zebra.com in developer events, where we have information on this webinar, this DevTalk. So that should be up later today. If Darren, either you can post that yourself or send it over to me, and I'll get it up there so people can have quick access to those links.
I will do that now.
All right. Okay, well, thanks again, Darren. This was really helpful. And even though I said there were no questions, we actually had quite a few there. So people were really engaged and wanting to learn more. So thanks again. And for everyone, we have posted our next DevTalk is going to be on Simulscan. So if you're wanting to learn more about any of the newest updates that have come out and look at it more from a developer perspective, we'd love to see you there. So we'll see everyone next month. Thank you.